Hello everyone and welcome back to this tutorial series about how to create a 3D game in C++ from scratch. In this 24th video tutorial we will talk about materials. In particular we will see how vertex shader, pixel shader and custom buffer can be used to make a material from the ground up, how to apply different materials over the surface of different 3D objects, and in the end, we will finally see a basic approach on how to add one or more objects into the scene. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to create materials. So let's start with the requirements. We need a C++ IDE, Visual Studio is recommended. The target platform is Windows. We also need DirectX 11 SDK, and last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. Today our goal is to create and use materials. But before to do that, we need to know what is and how a material is made. So, what is a material? A material is a substance or mixture of substances that constitutes an object. In computer graphics, material simply defines the way in which the surface of a 2D or 3D object is shown on the screen. Exactly for this fact, a material is mainly defined by vertex and pixel shaders. As we have already seen in the previous tutorials, vertex shader allows to define the way in which the shape of a 3D model must be manipulated. Pixel shader instead defines the way in which the surface of a model must be colored. A material is also composed by other elements. One of these are the textures that allow us to define together with pixel shader the way in which the surface of a model is colored. We can easily manage this texture through the usage of a simple vector. The other element that composes a material is the constant buffer that is necessary to send particular data like transform matrices or material properties like shininess and so on from the CPU to the shaders and so to the GPU. Once our material class has been designed and implemented, we have to instantiate it from the graphics engine class by adding a suitable method called createMaterial. But why from graphics engine class and not from render system class, for example? Because material is an high-level resource that is made by other atomic and low-level resources like vertex shader, pixel shader, constant buffer, that are instead resources created directly from the render system and more specifically from graphics API. And since material is not a resource created directly by the graphics API, the better place in which this resource should be handled is the graphics engine class. In this way we can create any number of materials we want, and for each material we are free to set our custom vertex and pixel shaders and or any number of textures we want. At this point, let's see a basic approach on how to make a scene with multiple objects. This approach consists simply to change the updateModel method in AppWindow class by adding two parameters: the position in which we want to place our object and the material that is used to pass the just updated data to the shaders. At the end, in the render method, we will simply call updateModel for each object we want to draw. Finally, we will be able to create a grid of different objects with different materials, like in these images. Very well, we have all the necessary information to start the implementation. As first thing, let's create a new filter in the graphics engine filter and let's call it material. At this point, let's create a new class called material. As we have seen in the introduction, since a material is composed by vertex and pixel shader, in the constructor method let's add two parameters, the path to the vertex shader file and the path to pixel shader file. So let's add also vertex and pixel shader pointers as attributes of the material class. Now let's go to App Window C++ file and let's copy paste the code of onCreate method, in which we compile the shaders directly into the material constructor method. At this point, we can substitute the paths to shader files with the correspondent parameters. Let's do the same thing with the attributes. Let's implement a bit of error checking. So good, now it's the time of textures. We can start to add a vector attribute of texture pointers. Let's also add two methods called with a lot of fantasy, add texture and remove texture. Very well. Now it's the turn of constant buffer. Let's add a new attribute and let's add a suitable method called setData. In the setData method, we can easily reuse the code already added in the onCreate method of App window. If the constant buffer has not been created yet, let's create it with the data just passed. Otherwise, simply update its content. Last but not least, we need to add the cool mode that, as we have already seen in the previous tutorials, allows to cool front or back faces of triangles. This is useful to render particular objects like skybox, where cool of front faces is necessary. So far, so good. Let's go to prerequisite header file and let's define the material class and its correspondent shared pointer. What next? Well, we have to instantiate our material class. So let's go to graphics engine class and let's add the create material method. Here we have to add the parameters we have already added to the constructor method of material class. Since the material instantiation equals to the instantiation of the various render system resources, let's copy-paste, for example, the vertex buffer instantiation code. Good! Now we are able to create any number of materials we want. The next method to add is the setMaterial method. This method will be used to bind a specific material into the graphics pipeline. This specific function has been already implemented in the drawMesh method of AppWindow class. Let's copy-paste it. In order to fix the various errors, let's also make Graphics Engine our friend class of material. Very well, everything is settled up. We can go to App Window C++ file and in the onCreate method we can start to substitute the code in which we compile the shaders with the creation of materials. As first thing, let's create two materials, one for the mesh and the other one for the skybox. The next step to do is to update the draw mesh method. Since now all these resources like vertex shader, pixel shader, textures, and custom buffer are now part of material, let's substitute all of them with a simple smart pointer to our material. And let's bind the material to graphics pipeline by using the setMaterial method. Let's remember to set even the cool mode. At this point, textures and cool mode should not be settled here. Let's set them during the material creation. As a very last thing, let's change the lines in which we set the data to constant buffer and let's set them directly into the material with the setData method. And let's see if it works. And it works! Nothing has changed from the last time from the rendering point of view, but now we are able to create and set more materials. It's arrived the moment to create a scene with multiple objects that are rendered with different materials. As first thing, let's update the update model method and let's add two parameters, a vector 3D position and a pointer to a material. Position will be used to set the position of the rendered model. Material, instead, will be used to define the way in which the model will be rendered. Now, since update model should update only the information about the model and not the light, for now let's try to separate the computation of light position by adding a suitable method called update light. Very well. At this point, let's go to render method and in correspondence of each draw mesh, let's call even update model by passing a specific position and material. Let's see what happens. Now we have a sphere rendered at the origin with a specific material. Let's try now to render more objects with different materials. In order to do that, we have in some way create other materials. But what if we want only to change the textures and not the shaders? In this moment, we would recompile each time the same shaders. To avoid this, let's add a new constructor method in material in which we pass a pointer to another material. Here we will simply get the shaders of the material passed as reference. Let's create the correspondent method in graphics engine class. At this point, in App Window C++ file, let's create two other materials, one with the earth texture and the other one with bricks texture. Let's try to create a scene with three spheres positioned along the x-axis with the three materials we have just created. Let's tune some light properties. As very last thing, let's create some scenes. Let's start by loading other models like Taurus and Susan models. Let's use them in the render method and let's see what happens. Very well, it works. Now let's try to create a grid of objects. Let's simply draw these three objects 3 times along the z-axis. Let's see if it works. And it works. As a very last thing, let's add a plane mesh under these objects. Here it's better to move our objects of 2 units along the y-axis in such a way to not intersect with the plane. That's all for now, folks. Today we have seen how to create and use materials. I hope you enjoyed this video. See you soon. Thanks for watching.